Okay, so this is the SAS homework. It is optional, which means that for graduate students you have to select 2 of the optional modules, and for undergrads anything is purely optional if it says optional. So you're going to log in at tinyurl.com/au-software to get to this magic place where all your resources exist. Peek in on the virtual desktop, click on the recycle bin to get a file navigator, and navigate to your directory where you're keeping all the materials for this course. Make sure that these files are accessible somewhere else, either your desktop or online at portal.office.com. Okay, so you got all that working. Now, we're going to first of all note that there's Guide Enterprise, which we're not going to be using. We're going to use SAS 9.4. There is also a different one called SAS Studio, which isn't here. We're not using that either. We're using this copy of SAS. I'm going to be following along in the same document I just showed you. So my suggested workflow for you is to have, well, first of all, there's a log file. There's an editor that you can create another editor file. So my recommendation is to have a scratch pad for just experiments and leave that as something you can cut and paste, erase off of, and have another copy of the editor that you use for your homework. Okay, that's my recommendation. Alright, let's show how to import data. So you say File, Import Data, and you want the standard data source to be CSV, which is right there. And then you browse, and you're going to go back into your OneDrive, find the file you want. I'm going to use just a standard file that I created at my website, so it's equivalent to your homework 1A. If you are really interested in SAS and you want to get the full benefit of the exercise, you probably want to use homework 1B to do this. But if you use homework 1A, it will be easier for you to follow along with what I'm doing because all the variables will be named in a very similar way. Okay. I'm just going to say Dietz as my member name. You can put whatever you want as your name, but that's whenever I type Dietz, then you're going to type your name there. Now it's going to prompt us to save this opening sequence. I can browse, and I actually have this file already, so I can just say like rewrite on top of this. Again, you always have to save to your OneDrive. And I'm just going to give it a different file name. It'll save it as .sas for you, or you can enter that yourself. Okay, finish. That sequence that we just did is optional, but it's not a bad idea to do it right now because then you can just flick back here and see what we just did. So this is by clicking on Date Modified, I can bring it right to the top. Now, I have done something on my virtual desktop that allows me to see all my file extensions, which means I can change my file extensions, and I explain that at the bottom of the worksheet. So I'm going to just show you how you can do this. You can just go down here and type File Extensions, and then this will pop up. No, it won't. Sorry. Type File Extensions, and then you click this thing that says Show File Extensions, and all these things should be applied. Okay, so mine are already checked because I already applied it, and then I hit the Apply button, and then I X out. I could turn it off here as well, But I want to do this so that I can see all my extensions. And then what I can do is I can right click and see, it's very hard for me to open with. I can say open with, but it's easier. I'm sort of cheating here, but I'm just going to rename this as .txt so that the computer recognizes it as a text file, and when I double click it, it will just open. And I can say, aha, that looks right. That looks like what this should look like. I'm not really sure. It just kind of actually wrapped around in a funny way, but oh well. Too bad. Okay, so if I then want to make it viewable by SAS, I'm going to have to rename it back again into SAS. And again, the computer's going to yell at me, but that's what I do to peek at the file. That's reassuring to me that I know everything's working right, everything's being saved correctly, and everything is connected. And it doesn't hurt to kind of check over here to see if it's coming over here. There's a little bit of a time delay, but it's showing up on the other side as well. Okay, so there's that. Now, for each of the following exercises, write and run the following code. Okay, now if you highlight just part of this and then hit this little running guy, then you'll only run the part that's highlighted. So that could be useful, but if you just want it to execute everything that's on the page, you don't have to highlight anything, and the default is execute everything. So what this is doing is it's creating a folder called calculation, actually a data set. So under libraries, you go to your work, and see now there's a whole spreadsheet created just for this one variable output. The letter X is 10. How exciting. And you can also see that the 10 showed up right here since it was just this little result. So that's what we did. So calculation is not a reserved word. It was just something we picked and named the sheet calculation because we called it calculation. Created a variable, put it inside the data set, and there you go. Very huge amount of work to add 4 and 6, I know. All right, so let's do a pie chart. You can type work in all caps like I did, or you can just make the capital letter work. Capital letter W. I don't know if you even need the capital letter to be, the W to be. I don't know if work needs to be capitalized at all. This SAS does not care if you put nice tabs and spaces in your code, but just to be nice to everybody, we should go ahead and indent properly so we can read, but again, the computer doesn't really care. All right, so here's our pie chart of our groups. And the groups in my data set happen to be named XY, WXY, VWXY. So that's just coincidental. So not to be confused with the other X and Y that are in the data set. So maybe we want to view this data set. So let's go ahead and view this data set just so you know what my data look like. So my groups are named like this, but don't confuse that with this X and Y, which are variable names. Okay? All right. By the way, just because we closed out the graphic doesn't mean it disappeared. Don't worry. If you want to see it, you should be able to see it. It shows up in one of these things. So if you close boxes, no big deal. If you close your editor, you're going to lose that, but I don't personally care. So you can choose to save it or not, or it will warn you. But I want to get back that window that I had here. So I'm going to say view contents only, and then I'm going to navigate back to my work directory, and then I feel better about that. Okay, but I'm trying to find my graphics. It was here. There it is. See, so even though I close it here, I didn't actually lose it. It just looks like I lost it. So it's very hard to kind of get used to navigating in here, but everything is here. It'll warn you if you're going to get rid of something. So just play around a little bit to see where things go when you close them so that you feel comfortable getting it back again later. Okay. Next we're going to run summary statistics. I'm going to try lowercase w on work just to see what happens. The worst thing that can happen is, well, no big deal. I'm being especially lazy right now because I just stuck everything on one line. It worked. So I guess it doesn't care about capitalizing work at all. So do what you want with that. All right. Now I want to just edit this one a tiny bit so that it splits by group. And the way I do that is inside here, after mode, before run, I put class group. And then I'm going to go ahead and split that. So it's going to give me a frequency by group, but then it's going to give me all this data, all this statistical analysis of each of the groups separately, instead of what we had before, which is the groups together, all combined. Okay, so I'm more interested that you understand the structure of what's going on. This data that I'm looking at is completely bogus. I made it up. So anyway, it's just understanding how to get the analysis out of the computer. All right, what if I want to know how big my data frame is without just looking at it and scrolling? Like, for example, I could click this, but it's pretty big. So I don't want to just scroll down to the bottom. What a pain. I don't know how many things are in there. It's just going to take forever to find it. So what I'm going to do instead is I'm going to say this. This is definitely going to take a lot of typing. Knobs means number of observations. Okay, so what is going on? I'm going to be looking at this work file that we've been working at, the same data set. And then I'm going to put this probably on the screen, I guess it means print. And then I'm going to look up here and see that it's 10,000 units, 10,000 observations. Okay, so very exciting. Lots of work just to do that, right? But these things are more generally useful. Okay, writing a random set of data with a normal distribution. So this is new data. I'm going to call it new name. So I'm going to add 100 to everything and then multiply the normal by 15. So I'm going to have a mean of 100 and a standard deviation of 15. I'm just going to put some random digits here. That's called a seed. It doesn't really matter what you put as a seed as long as there's some seed. But if you want different results later, you're going to have to create a different seed. So the reason why you create you seed your random variables so that if you run the same exact code, you get the same exact answers and you don't want any randomness. So it's pseudo-random because it feels like it's random, but you can completely reproduce it. And then if you want a different random seed, you just change the digits around a little bit and you'll get a different random seed and it will look like it's all different. But it's all traceable, it's all repeatable. So that's why we seed our random number. Seed as in S-E-E-D, like think of like you're putting seeds in the ground, that kind of seed. All right, so we've just created something called new name, only 200 of these. Oh, well, something went wrong. Maybe double check that I wrote the code correctly. That's weird. Well, that's not nice. Let me pause and see what happened. Well, these things are always obvious in retrospect. I forgot the semicolon because I'm used to working in Python. So this should just work this time, hopefully. And then when I open this up, hopefully it'll be full of random data, which is what we wanted. Great. Okay, so usually when your code doesn't work, it's just some tiny little typo. That's like 99% of the time. And then if that's not what it is, come see me and we'll figure out what went wrong together. That's part of what office hours is for. You just keep track of all your questions. And then we go. Okay, so let's go ahead and look at this, see what it does. So this unit variate command, it gives us a lot of output, including but not limited to, there should be a histogram in here. So that's good, there it is. And we can put groupings in it this way. I'm going to run this again. There's so much stuff in here. So each group is being dealt with separately. And here's our histograms. Okay, so we got our histograms for V, W, X, and Y. Well, it seems like a lot of work. What if we just literally want a single histogram and we don't want all that output? Well, let's try this one. And this is just going to give us the plain old boring histogram. And you're like, well, what is this other stuff? Well, that's from the last thing we did. So all that stuff is still there. It's just one big output file. Okay. Next, we're going to do a 95% confidence interval. You can set this alpha to be anything you want, but right now we're just using 95% confidence level. Okay, so my instructions here say run it once without worrying about grouping, and then we're going to run it a second time with grouping. So before the var, we're going to put class group. And see, it's with and without. So we got confidence interval for the whole thing, which is completely actually meaningless. This was meant to be grouped. This data was meant to be grouped. And so that's why the grouped analysis seems to make a lot more sense. It just does. Okay. We can create a correlations matrix, and you can make a matrix with all the various variables you have laying around. If you just have X and Y, just use X and Y. T and S can be thought of as numerical as well, so you can stick them in there if you want. I want a different procedure. I want a correlation matrix, var X, Y, T, S, however many you like, and then a semicolon. And then you get this matrix. This one down here, the second one. Notice there's going to be ones on the diagonals. That happens with any correlation matrix. Sometimes you'll see software where they're more efficient. They only give you like half of this triangle and they get rid of the diagonal just to make your life a little easier, but it's all the same information. And see, if you don't put in TNS, it's going to be much smaller. You're just going to get a smaller box, but they're still going to give you these crazy ones, like you don't know that X is correlated with itself, seriously. But anyway, most software puts it in there for you. Okay, next is going to be QQ plots. Okay, we're going to do this guy. I get a QQ plot, lovely QQ plot. QQ stands for quantile. Okay, now the next series of commands we're going to run are going to be all different kinds of scatter plots, variations on a theme, and they're going to be we're starting off with SG plot, and you can also put a title in here if you want. And then you want scatter x equals x, y equals y, and then run. So what this means, if you zoom in carefully, you'll see that this x here is actually blue because that x is coming from, even though you typed it, it's coming from the software. That's the SAS reserved word that means the horizontal axis, or this y means the vertical axis. It just is coincidental that we also named our horizontal axis x and our vertical axis y. We could say scatter x equals y, y equals x, and then it will flip them around. Okay, so that's what that's doing. Okay, so you've seen this before in homework 1A. Now I'm going to add something to this. Instead of scatter, I'm going to say regression. And I'm going to include these two additional pieces, which I'll show you when they pop up. So confidence limits are on, there are confidence bounds here and here on the data, saying like where 95% of the data should fall. But there's another boundary here, a very thin boundary. It's the error bound on the regression line. In other words, it's giving you how accurate it believes the prediction line itself is. Like, where does it expect the mean to be? We have gobs of data, so you have to squint to even see that there's error bars around this median prediction line, as opposed to these are easier to see, these 95% limits for the data set itself. That's easy to see. Okay, what else do we want to see? Oh, there's something cool called Ellipse. I haven't seen it often. I just see it here actually. It's kind of cool. I'm sure other software does it. I haven't seen it anywhere else. And it just is drawing an ellipse telling you where most of the data are living. Pretty cool. Alright, now I'm going to make it really fancy, and notice it's not SGplot, it's plain old plot. And so we're going to change all the guts in here. We're going to say, and you don't need to watch me type all this, so let me pause. Okay, let me just try running it like this and see what happens. It's kind of not that exciting yet. So I've got symbol 1 and symbol 2 interpol. That's what my problem is. I said interp instead of interpol, so I made a typo. And so what'll happen is it's still not working. Great. Let's go back and figure out what we did wrong. Value is dot, color is deep pink and vibrant green. And I'm going to make symbol 3 Let's try that. Let's try that. Forgot the semicolon. Whoops. So that's still not doing what I want. So I'm going to try putting in a fourth color. I just think I found my problem. But anyway, you can just say green or something like that. Let's try this. All right, I'm going to pause this for a second. Okay, so in this case, my typo was that I did not put the number 2 right there. And so what it interpreted was it made a separate plot for that line, and so every time I looked at the output I kept seeing the same thing, not realizing that everything I was asking it to do was being done correctly. I was just not seeing it, and I'll show you now what was going on. All this stuff kept plotting, but then it would plot what I wanted followed by this thing, which I didn't want because I didn't put the number 2. Just tiny little typos. That's the way computers are. Okay, so this is more like it. This is what I want to show you. A couple things I want to point out. One is that notice that V, all the little red dots for V, are being plotted first and followed by W, X, and Y. So they're in layers. So there's a problem with that because you get a false sense of where the data are unless you've been looking at it. So we've been looking at this hopefully, and so we have a sense for where the data are. But be aware when you see these layers, you're only possibly seeing the top layer. So that green is obliterating everything else that you're looking at. Then the thing where I typed in RL, that's a regression line, and that is black. Okay, so so we have our 4 groups, or however many groups you want. I have a regression line, and I kept plotting this thing, which was not useful. But you can see I kept trying to change the symbols. Let me show you what was going on here. When I didn't specify too many groups, it just plotted everything else as little pluses. It wasn't splitting it up and plotting it really the way I wanted it to. So that's what was going on there. Once I got all the colors defined, it was plotting it the way I wanted, but it wasn't adding the regression line because that was my bad. Okay, so here's the regression line together with everything. All right, so now it's doing what I expect. All right, I'm going to take a breath for a second. Okay, so what I want to do is the problem with the output I just had is that it wasn't grouping and giving me individual fit lines. It was just giving me the general fit line. So I would prefer to have 4 different fit lines. So I have a different syntax for doing that. And this looks very confusing, but let me see if I can explain to you what's going on. So this green one is easier to see, is the X. So that's my group capital X. And then this green fit line goes with the green dots. And so forth. The blue line goes with the blue dots, the red line goes with the red dots, and this, I don't know, brownish line goes with the brown dots. But those colors, oh my gosh, they're kind of hard to see. But they do the trick. It's all right. It's acceptable. Maybe you want to look at some of your other plots to get a sense for where all the data live. But anyway, just giving you more tools. Okay. So here's how we create an empty variable, and I just want to do this to make sure it makes sense. So you're going to define your data set again, and you're going to be working on this data. You're going to be creating a new variable, and so let's go ahead and do that and see if that works. So we're going back to our main data set, and we see that a new column has been added. It's completely useless, but now we can put stuff there if we want. We can put calculations or whatever. Okay, so now we're going to use the same structure with an if statement so that we can recode a variable. So for example, I'm going to say if t equals 0, then gender equals female. And it's going to create a variable for me, else gender equals male. And that's what we're going to have as our variable, the word gender, and we're going to go ahead and run this and see if that one works. And there I go. So now I've actually recoded a variable using this same structure. You always have to close out your view tables some software, and I think this is one of them, won't let you edit when the viewer is open. It doesn't make sense to me, but anyway. Now I'm going to do a scatter plot with regression lines for each subgroup. I'm going to use something called ODS graphics. See, I'm making typos, so I'll go back and fix them now. Okay, let me try that. So this is similar to what we had before. It just gives you a slightly different output for that. Okay, now let's make a sorted line plot. This is the hardest thing I found to do in this environment, and it's convoluted. It would be great if there's another way to do it. I don't know of another way to do it, but it's okay because it gives us a chance to explore some other tools that we might use in other circumstances rather than just making a sorted line plot. Okay, so first of all, a lot of software is really resistant to changing a data set once you have it. And when you sort a data set, there's always the question of whether you're going to replace your existing data or if you're going to create a new column of data. So this kind of gets around all those questions. So I'm going to look at this data. I'm going to look at the X column. I'm going to create a new X column. Now let me see what happened in here. See, I've got a new X column, and right now it's identical to the old one. All right, the next thing I'm going to do is I'm going to export this I'm going to keep new X and output new X by new X. I mean, that's kind of obvious, but it's not. So let me explain that for a second. This is the part that I'm running. So I'm saying I'm going to create a new table, and I'm going to name it new X, and I'm going to keep new X, and I'm going to output new X. I'm going to sort by new X. Why would I have to say all that? Well, in a spreadsheet, often you want to sort by one thing. Like maybe you want to sort by last name, but you want to keep all the rows together. So when you say, you may say sort a spreadsheet by last name, but you don't want to replace, you don't want to just replace that one column. You want to rearrange the entire spreadsheet according to that new rule. That's not what we're doing here. So that's why it seems awkward, because we're doing something that's a little bit unconventional. We're saying take the entire spreadsheet, now it's just one new variable, but I made a new spreadsheet for it, and I'm sorting the whole variable by that variable, and I'm replacing the variable that I had with the new variable. So it's a lot of speaking, but for the computer you need to be explicit, because a lot of times what we just did would be dangerous if you did that to a spreadsheet, because you would like rearrange all your data. So you have to sort of go out of your way to tell the computer, no, that's really what I want. Okay, I'm going to create a new data set, and I'm going to merge my work deets with my new X and go ahead and run that. And so now I have a new data set, not new X, but my whole new data set. So now I have everything I had before plus something called new X, which is a sorted copy of X. All right, so that's a lot of just wasted breath. Okay, but that's what we have. Now we want to go ahead and we want to create a counter column alongside, because otherwise we can't plot it. So data new x, set new x, n equals underscore capital N underscore. So the lowercase n is going to be our new column name and all the contents. Underscore capital N underscore means what line are you on. So the two underscores on either side are saying it's already a variable that's defined by the system, and we're just using it and we're just tacking it in there. So let's go ahead and see what happened. Now we should have, sorry, over here. So n is simply the line number. That's all that is. We just tack the line number onto the data. Now, finally, after all this work, we're going to go ahead and gplot this and the star is not multiplying, it's just a symbol that means where the x and the y axis are. After all that, this is kind of like a QQ plot. This is essentially what we're doing. We're saying we're lining up all the data, the x data, sorted from the smallest value in the data set to the highest value in the data set, and the smallest value is like 110 or negative 100 or something, and the highest one is about 90. And we're just going to put it all in order and show you what the data look like. So again, it's very much like the feel of a QQ plot. Okay, so that was painful, but we're done with it. Okay, now let's do something more fun. I mean, not that that wasn't fun, but you know, it was a lot of work for not much. So we're going to go on to Anova. Okay, so I have to send in this argument because normally max points is 5,000, and I have more than 5,000 data elements. I have 10,000, so I'm just telling it max point is 11,000, just so we have enough room to do this. ODS graphics off. I guess sometimes it's important to turn it off. I'm not sure what happens if you don't turn it off, but anyway. This is kind of beautiful. This is one of my more favorite graphics, when you do box plots side by side. And this really helps you understand what Anova is doing. It's doing this comparison of numerical variables against categorical variables. And so this is a beautiful plot that shows you where your data live and so forth. And so now you can see why the bottom is down here and the top is up here. This is actually very similar. Like, you can see that a lot of your data were just the extreme values were kind of defined by group V, more or less. Anyway, that was kind of fun. Let's do chi-square and then we'll get to save our work. So one more thing we need to do. Proc freak data is the data we've been working on. I don't think you need to capitalize group, but the reason I am is to sort of signal to you that it's my variable name, not a reserved word. And there we go. All right, and there's our chi-square, and we've split. I've decided to split T against the groups, but it could be any two categorical variables you want. And then it tells you that this is highly significant. Well, gee, I'm shocked. Okay, so happy about that. Now, at this point, we're going to save our work. So if you like these graphics, you're going to have to kind of save them off. You're going to have to use some kind of screen capture to save the ones you like. There used to be better ways of doing this, but so far I have been unable to do it. I used to be able to just say, hey, save as web page complete, and it would automatically save all the graphics, which was a beautiful thing. But it doesn't work anymore. So if you say File, Save As, and you say web page complete, Unfortunately, you will not get the graphics. You'll just get, like, all these things will come out. So if you're just trying to save the numerical calculations, saving as web page complete might be useful for you. But if you're trying to save the graphics, it's going to be hard. All right, so what I do want you to do to save for your homework, I want you to save your log file, and then you're going to have created a beautiful file over here with all your work in it. But first, let's show how to save the log. Okay, I'm going to save file, save as. I'm going to save a log file. Make sure you keep making sure that you are in your OneDrive. This is just kind of annoying. Okay, so saving my log here, .log. If you don't type .log, it should do it for you. Alright, so that should be saving your log, and so then you can go over to the virtual desktop and make sure, what did I say, saving my log. You can just sort by date modified to find it again. And it may or may not let you open it. Oh, how sweet. I didn't have to change the extension on that guy. This is all the stuff I did. All the stuff I did. So I want you to save all the stuff you did. The good stuff, the bad stuff, the stuff that didn't work, all of it. Every last thing. Save it. Then you want to save the good stuff. And one thing you can do if you forgot to save all the good stuff is you can make a copy of this. You can open it and save it. Make a copy and just save the stuff that you like. And then run it, but you have to run it to make sure it works, because I'm going to look at your data. I'll change the directory names. Don't worry about the directory names, but I need your data and I need your file, and I'm going to run it and make sure it works together. Okay? So the way you're going to save your SAS file, let me give you just a demo. Let's say, let's just like, let me just do this last one again. This thing. I'm going to copy this. Apparently it doesn't want me to do that. Paste. And of course I got to get rid of these line numbers. I'm going to run this to make sure I copied it correctly. Okay, fine, I copied it correctly. Now, let's say this is the entirety of my homework, which it's not, but let's pretend it is. Then I'm going to say File, Save As, and this is going to be my SAS folder. Sorry, my SAS, yeah, my SAS output saving now. .sas, and I'm going to save that here. I'm going to go back to the virtual desktop and make sure it showed up, and here's where you cannot read this. You can't open this, but if I wanted to, I could open with, or like I said, this is my trick. I'm going to rename it as txt, and then that way I can just click and read this and make sure it has what I expected it to have, which is all your good code. I don't care if you leave this extension as txt. I'll change it if I have to. Don't worry about that. I might just cut and paste it all into a window. It might be easier than trying to change directories and all that stuff. So anyway, it can end in SAS or txt as far as I care. I don't care. You might want to check here to make sure that all this came through. Well, it's not all perfect, but there we go. Now, if I want to just make sure this is flushed, it might help me to make sure SAS output saving now should show up here. And this is where you just sit here and wait. Make sure it comes over to somewhere else. Just don't close down the virtual lab until you see those files appear somewhere other than just the virtual lab, because it's kind of in its own little sandbox here, and I just want to make sure if you see it show up in the virtual lab, certainly it's okay to close down SAS, but I would not log out or leave the virtual lab. Come on, computer. Where am I? So this is the one I'm worried about. I want to make sure this output in this log show up over here. Saving my log here showed up. How about just A to Z? Let's see if that helps. I don't know why SAS output is not showing up. Nope, it's here 2 minutes ago. Just like this clock thing didn't seem to work. There we go. Okay, I now see that my SAS output and my log have safely arrived. Now I'm ready to close down everything on the virtual computer. I can close that down. I can close this down. Okay, now I'm happy. And I can close this down. I can even close this guy. I mean, I can close down my window, everything. Okay, everything can close now. All right, so then you're going to upload the data and your SAS file and your log file. Okay?